Lesson 13.3, Angles and Polygons. We're going to fill out this table. So when we look at a quadrilateral, we want to know how many sides it has. And a quadrilateral, if you count them, has 4 sides. When we talk about a diagonal line, what we're talking about doing is if you look at each of the 4 vertices, because each polygon has the same number of vertices as it does sides. That's where 2 sides meet up at a corner, so to speak, at a point. So when you look at, say, if I picked this vertice right here. Well, let's see if I can. From this one vertice, you can see that it's already connected to 2 of the sides. So I'm going to connect it to the other vertice that it's not connected to. Okay? So by doing that, I've drawn one diagonal line. And when I draw that diagonal line, I've basically cut the quadrilateral in half and I have formed 2 triangles. We're basically going to be relating everything back to triangles for degrees because we know each triangle has 180 degrees. So I would know, since there are 2 triangles inside of each quadrilateral, there must be a total of 360 degrees inside the quadrilateral. For the pentagon, there are 5 sides. The number of diagonals, again, I pick one vertice and I connect it to all vertices, but it's already connected to 2 by their sides. So I draw 2 diagonal lines and I form 3 triangles. There's 1, 2, and 3. So when I find the number of degrees inside the pentagon, I would take 3 times 180 and I come up with 540 degrees. For the hexagon, there are 6 sides connecting one vertice to all others. I would have to draw 3 diagonal lines. That makes 4 triangles, and 4 times 180 is 720 total degrees. For the octagon, 8 sides connecting one vertice to all others. Is 5 lines forming 6 triangles, and when I multiply that by 180, I get 1,080 degrees. Okay, so if we're going to generalize and we're looking at the relationship between the number of sides and the number of triangles formed, we can see that in each shape, the number of sides minus 2 will give you the number of triangles. So I'll put that down here. The number of triangles is equal to the number of sides minus 2. And then to find the sum of the angles in a polygon, we would take n minus 2, because we need to know the number of triangles, and then multiply by 180. So here is our heptagon. It's a 7-sided regular polygon. We want to know what the measure of each angle is in this heptagon. So what's different, first of all, we have to know the total number of degrees first. I didn't measure one of the angles and give it to you and ask you to find a missing angle. I'm asking you for each one. So we have to understand something true about all regular polygons. In regular polygons, just like the equilateral triangle, the angle measures are equal to each other. We talked about that. If the side lengths are equal, the angles opposite the side lengths are equal. So if it's a regular heptagon, it means that all side lengths are equal to each other. Therefore, all angles are equal to each other. So when we find the total number of angles in the heptagon, we will divide that by the number of angles or vertices to get the measure of 1. So we have another formula that we want to add to this. So since we want to apply this, the number of triangles would be equal to 5 because there are 7 sides in a heptagon. So 7 minus 2 equals 5. So the total number of degrees would be and that equals and if we need to find the measure of just one angle, we're using this formula because for a regular polygon, the measure of each angle is equal. So therefore we would take the total number of degrees and divide by the number of sides. So we want to divide this number by 7. And we'll round it. So each angle is equal to approximately 128.6 degrees in a regular heptagon. Some samples. An interior angle of a polygon is an angle inside the polygon, and you can find the measure of an interior angle of a regular polygon by dividing the sum of the measures of the interior angle by the number of sides. We just did that with the heptagon. Here are your formulas, so they will be on the PowerPoint with definitions. So in example 1, finding the sum of a polygon's interior angles. Find the sum of the measures of the interior angle of the polygon. So it's 5-sided, but it did not tell us that it is regular. So in this case, we're just going to assume, and we're not going to find the measure of just one angle. But since it's a pentagon, it has 5 sides, n minus 2 times 180, and this is in our table as well, and we found that to be 540. Okay. Find the sum of the measures of the interior angles in the polygon. Count the number of sides. Since it's an octagon, there are 8 sides, and this is in our table as well. So I'm not expecting you to copy down all of these examples, and you will find these in the textbook. So those of you that took a textbook home will have the examples in the textbook. Okay, we already did this example when we had the picture of the tambourine. So the number of sides is 7. There's the formula that we're going to use because it said it was a regular heptagon. And we got approximately 128.6 degrees. So let's take a look at some exterior angles. When you extend the side of a polygon, the angle that is adjacent to the interior angle is called exterior. And in this diagram, angles 1 and angles 2 are exterior. An interior angle and an exterior angle of the same vertex form a straight line. They form a straight angle, so they are supplementary to each other. So if we knew or had enough information to have the interior angles of this triangle, we could calculate the measures of either angle 1 or possibly even angle 2. And that's what we're going to be doing in the next examples. So example 3, we want to find the measure of an exterior angle 1. Okay, find measure of angle 1 in this diagram. So we're given a lot of information. We can see that there are 5 sides, right? So if we added up all the degrees they gave us on the inside as a pentagon, we know that it should have 540 degrees total, so we could check that. But we also know that angle 1 and the angle that is 87 degrees are supplementary to each other. So angle 1 plus 87 degrees equals 180. With a little bit of math, we can find angle 1. So the measure of angle 1 is 93. Try another one. All right, we need to find It says the diagram shows a teapot in the shape of a regular hexagon and we want the measure of angle 2, but they haven't even given us the measure of angle 1. But they gave us enough information to calculate it. Because it is a hexagon, it is 6 sides, so we can use the formula n minus 2 times 180 divided by n, and it would look like that because n is equal to 6. So because the measure of angle 1 and the measure of angle 2 would be 180, using that formula we'll find the measure of angle 1. So if one angle is 120 degrees, 120 degrees plus the measure of angle 2 would equal 180. Therefore, angle 2 will equal 60 degrees. Okay, so the sum of the exterior angles at each vertex of a convex polygon has 2 exterior angles. If you draw one exterior angle at each vertex, then the sum of the measures of these angles is 360. The calculations below show that this is true for a triangle. So measure of angle 4 plus the measure of angle 5 plus the measure of angle 6 is equal to 180 minus measure of angle 1 plus 180 minus measure of angle 2 plus 180 minus measure of angle 3. So we can use this information for our next example. We're going to find the unknown angle measure. We know that the sum of the exterior angles of any polygon is 360. So 106 degrees plus 100 degrees plus 81 degrees plus x must equal 360. Combine by adding like terms to find x.